Hey guys, Dr. Butts coming out with a fantastic chemistry video, and today we're going to learn all about acids, bases, and buffers. Now, this is a cool lab, guys. Why? Because acids are cool, bases are cool, and buffers are cool. An acid is a proton donor. Think citrus, citric acid, for example, is an acid. Bases are proton acceptors. Think, well, commonly in your home, bleach is a base, believe it or not. It feels really slimy in your hands. That's a good indicator you're working with a base. Buffers resist changes to pH. Now, what's pH? Might want to look that up before we start today's experiment. You should already know by watching the pre-lab videos. All right, it's going to be awesome. We're going to do a whole bunch of mixing together, doing different chemical reactions, seeing what happens to pH. It's going to be epic, guys. Now, let's not waste any more time. Let's get after it. Let's get it done. All right, class, we're going to do part 1 of experiment 8, pH determination. So, what we have is we have a series of solutions we need to test, and we're going to use these little things called pH paper, just like this. Okay? Essentially what's going to happen is as we test each sample, this piece of paper is going to change color depending on the pH. As you can see, pH 1 is a reddish color, pH 12 is a dark blue, and all kinds of colors in between. So we're going to do our best to match the color on our paper to the color on the chart to determine what the pH is. And the first thing we're going to start with is water. I have a little bottle of water here, so I'm going to take a little dab. Doesn't take much. There we go. That's more than we possibly could need. And let's compare the color. All right, now water should be neutral, but if the water is not completely pure, or if it sat out overnight, it could be a little acidic, and I think today's water is somewhat acidic. It's pH 6. If you want to read the color, it's right around pH 6, but that's okay. Just write down what you see, pH 6. Should have been neutral, but hey, can't have it all. All right, next, we're going to test a solution of sodium chloride. So let's just take a little dropper. I'm just going to drop a touch on here. There we go. There's the color change. So now I'm going to take a look here. Nope, 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 nope. Well, maybe, no. It's one of these two, and you're going to have to determine which one you think it is most like. Write that down in your data sheet. That was sodium chloride. Next up, hydrochloric acid. Now this is an acid, so obviously we should be down in the red zone. Let's take a peek. There you go, it's red. Hydrochloric acid, the name kind of gives it away, right? So there we go. I'll let you make the determination of what the pH is, whatever you think the color matches the best. Okay. Next up, hydrochloric acid. Oh, pardon me, sodium hydroxide. Hydrochloric acid we just did. So this is sodium hydroxide. And look at that, dark, dark blue, so down in this range. Again, I'm not going to tell you what it is. You have to make the determination for yourself. The next up is a buffer. If you don't know what a buffer is, make sure you review the manual, because we're going to need to know that for part 2. All right, here we go. There's our buffer. Again, it's kind of a dark bluish color. Again, make your own determination of what color you think that is. Which one do you think it matches up with the most or the best? That was the buffer solution. Next up, fruit juice. So let's take a sample of fruit juice here. There we have it. Let's kind of compare the colors here. All right, that's fruit juice. Next up is instant coffee. Nothing like a good cup of coffee in the morning or in the mid-afternoon. Here we go. Let's see what color you think that matches with the best. As you can see, there's, the trouble with color tests is it's all in the eye of the beholder, right? Next is lemon ammonia cleaner. There you go. Dark, dark blue. There we go. That's lemon cleaner. And last but certainly not least, a solution of sodium carbonate. And there you have it. Write down whatever color you think it matches with the best. And there you have it. All right, guys, so that is the end of part 1, pH determination. Stay tuned and we'll move right into part 2. See you there. All right, class, now we're on to part 2, pH determination of solution after a change. Now, what we're going to do is we're going to put water and buffer into a few of these wells, and then we're going to hit them with a little bit of acid solution and a little bit of base solution. Then we're going to mix the acid and base together and see what happens. All right, so first things first, let's put a little bit of water into the first well of the spot plate. I'll put 10 drops in. I put 10 drops in. So now let's see what happens when we add a drop of HCl. Now you already know the pH of water. We tested it in part 1, so let's get it from that part. I'm going to put a drop of acid in there. Just a drop. So this is the HCl solution. Let's give it a little stir. There we go, good enough. And now let's test the pH. Now remember, and there it's red. So let's get the bottle in here to see if we can check the color. And now, oops, turn it around. So it looks like it went to pH 1 or 2. Okay, so write down all the information in the data table, including the pH of the water once we added a drop of acid to it. Okay? Now remember, I'm just doing the procedure. You have to figure out what's going on in the science, okay? Just remember that. If you have any questions, you can email your professor. Now I'm going to do the same test, but I'm going to do it in buffer solution. The same buffer solution we used in part 1. 10 drops of buffer solution. And now I'm going to add 1 drop of the acid solution. Okay, remember the buffer from the first experiment? You wrote the pH down for it. It's the same buffer. Now I'm going to add 1 drop. Give it a good little bit of a mix. Okay. And we'll dip the thing. And there you go. Now notice the pH here didn't go to red. In water, it went right to red. So you have to kind of think about what that means in terms of what buffers are. Okay? All right, next up, we're going to add a little bit of sodium hydroxide to water. The same water as before. Sorry, the same water from the same bottle as before. A few more drops. There we go. And now, water is the same pH as it was above, so you don't have to do it again. Just write it down from what you have from part 1. And now I'm going to add 1 drop of sodium hydroxide. There's 1 drop. Let's give it a little stir so we can get a good mix. There we go. And let's dip the pH paper in. And look at that. Drastic color change. So you can write down whatever color you think this matches with the best. All right. Now let's do that same experiment, but now let's do it with buffer solution. Okay, there we go. 10 drops of buffer. We're going to add 1 drop of sodium hydroxide. There we go. Let's give it a little bit of a mix. There we go. Now let's try the pH. It's the same buffer from part 1, guys. Let's see if we can compare the colors. There you go. Write that down in your book, whichever color you think it is. And now for our final experiment in part 2, we are going to test HCl added to sodium hydroxide. So let's push the plate up a little bit, get it clean well. We'll use the one here. So we're going to add 5 drops of sodium hydroxide. I'm going to add 4 because we're running out of space in the well. So I added 4 drops instead of 5. And I'll add 4 drops of hydrochloric acid. Let's try to do equal volume as best we can. And give it a mix. I want to get this one thoroughly mixed if I can, so we can really see the result, because acids and bases should react to give neutral pH, but it all depends on the volume too, right? And there we go. So then now compare the colors here. Get the glare out of there. It's kind of greenish, so I'm going to say it's probably closer to 9. So the pH came down slightly. And there you have it. There's the end of part 2. All right, guys, so now that is also the end of experiment 8. So make sure you do all your calculations, make sure you get it all done up nice and neat, and submit it to your laboratory instructor. And with that, I want to wish you all good luck and good chemistry. See you soon.